When we're talking about variables, it's important to understand how we will be measuring these variables when we get to the point of analysis. In order to do that, we have here scales of measurement. Within the scales of measurement, we've got two umbrella designations, the first being categorical and the second being continuous. Categorical designations relate to qualitative measures, whereas continuous designations relate to quantitative measures. Um, Dichotomous, nominal, ordinal, interval, and ratio are all levels of measurement, scales of measurement, I should say. And they do differ from one another, but the differences between them, especially when we're talking about ones that are right next to one another, the differences between them can be very, very small, very minute. So you're going to have to pay close attention as to what these differences are, so that you're able to designate that this is indeed an interval measure versus a ratio measure, so on and so forth. So first, under the categorical umbrella, we'll start with dichotomous measures. Dichotomous measures pertain to variables that have two categories with no intrinsic order. These are some questions. You could fill in the blanks here as far as what questions or statements you might be thinking of. But if I were to make a particular statement, whatever it may be, true or false, you only have two choices, true or false, thereby making it a dichotomous measure. If I were to ask you a yes or no question, you then have two ways to answer that question, yes or no. For example, if I'm talking about sports specifically, I might have the measure of contact versus non-contact. So if I want to create a dichotomous measure within the category of sports, I might divvy it up between contact and non-contact. So this way that becomes a dichotomous measure. So essentially, if I were to list football, is that contact or non-contact? Obviously that's contact. If I were to list baseball, is that contact or non-contact? Obviously that's non-contact. Boxing, contact. Golf, non-contact, right? So that's a dichotomous measure right there, the variable of sports, at least in the way that I've communicated it here. In addition, also in the realm of sports, we have men's and women's sports, male and female sports categories. So that's also dichotomous in the sense that, are we talking about men's basketball or women's basketball, right? So it's dichotomous. We're talking about basketball, let's say. Are we talking about the men's division or the women's division? So that also is a dichotomous variable. So that's dichotomous variables. Again, two categories with no intrinsic order. Examples being true-false questions, yes-no questions. In the realm of sports, it'd be contact versus non-contact, male versus female sports, right? Next, we have nominal measures. Nominal measures are variables that have two or more categories with no intrinsic order. Very similar to dichotomous, as you can see, right? Two categories in dichotomous with no intrinsic order, but in nominal, it's two or more categories with no intrinsic order. This definition right here alludes to the fact that dichotomous variables can, in fact, be considered nominal variables as well. So if you have two categories with no intrinsic order, you can have certain publications refer to them as nominal variables, nominal measures, despite the fact that they are indeed dichotomous. So dichotomous would fall underneath the nominal category in certain instances. So it depends really, it's more subjective than anything else. So nominal pertains to two or more categories with no intrinsic order. So you can have 3, 4, 5, 6 different categories with no intrinsic order. And in the examples, I've included race, ethnicity, city, state, perhaps where you're living now or where you were born, and sticking to the theme of sports, your sport of choice. For example, here, there's no intrinsic order as to, if we were to talk about sports here, for example, basketball isn't intrinsically better than football. Football isn't intrinsically better than basketball. However, me personally, I love football. I love boxing. And I might say that I think football is better than basketball. I might say that boxing is better than golf. Me making that designation does not show intrinsic order, it shows extrinsic order, meaning that I am determining the order, or rather, right, the order there, as opposed to the order being there before I get to this particular arena. So sport of choice, the answers could differ from person to person. I might like football and boxing. You might like basketball and golf. Neither of us are right and neither of us are wrong, right? So that's nominal. The next measure is ordinal. Ordinal pertains to two or more categories with intrinsic order but not along a continuum. Now let's break down this definition a little bit. Two or more categories, very similar to nominal, but here there is intrinsic order. Whereas nominal, there is no intrinsic order. In ordinal measures, there is indeed intrinsic order. Two or more categories with intrinsic order, but not along a continuum. A continuum, if you want, you can think of it as a number line. And if you were to think of it as a number line, once we get to the examples, it'll make more sense, right? So taking that number line example here, for instance, when we get to the example of level of education, if getting a bachelor's degree took as many years as getting a master's degree, which would take as many years as getting a doctorate degree, then it would be along a continuum. But instead, we know that the undergraduate degree, the bachelor's degree, the associate's degree comes first, then the bachelor's degree, then the master's degree, and then the PhD. However, it's not along a continuum because it could take a longer period of time to complete your undergraduate degree versus one of your graduate degrees. It actually could take a shorter period of time to complete your undergraduate degree and an even longer period of time to complete your graduate degrees. We just know that there is a rank. Undergraduate comes first, then the graduate degrees come second or come after that. But there's no continuum there to communicate because it's not consistent. The difference between a bachelor's degree and a master's degree isn't the same as the difference between a master's degree and a PhD, for example. Therefore, it's not along a continuum. Another example here would be along with sports, well, in the arena of sports, I should say. If you win gold, I win silver, and our mutual friend wins bronze in a particular competition, let's say we're running on the track, you win gold, you ran the race in, let's say, 5 seconds. I might have run the race in 7 seconds. And our mutual friend might have run the race in 10 seconds, right? So think about it like this. If it was along a continuum, then gold, silver, and bronze, the distances between gold and silver and the distance between silver and bronze would be the same. But here we see that you ran 2 seconds faster than I did, winning gold. I won silver. But the person who came in third, won the bronze, ran 3 seconds slower than I did. Yet here we are. You won gold, I won silver, and our mutual friend won bronze. But the distances between us, all three of us, is not the same, is not on a continuum. It's not consistent. Here I have Likert scales also as an example, and Likert scales are thought to be ordinal measures. However, there are some circumstances where, for the purpose of statistical analysis and, more importantly, descriptive and inferential statistics specifically, you may see Likert scales be assumed to be in the continuous arena. So this way you're able to have averages, you're able to have measures of central tendency like mean, median, and mode, measures of dispersion like range, variance, and standard deviation. But inherently, Likert scales are ordinal measures that are sometimes, here being sometimes artificially transformed into continuous measures, right? I'll talk more about Likert scales in just a moment in the context of continuous measures. But just to close out the example of ordinal measures here, we have birth order. For example, I might be 10 years older than, let's say we're all siblings, right? We have 3 siblings, me, you, and our little brother. So I am, let's say, 5 years older than you are, but let's say our youngest brother is 10 years younger than you are. So the difference in age between me and our youngest brother, is 15 years, but the difference in age between our youngest brother and you is actually 10 years. So even though there's order there, it's not along a continuum, Just by me telling you that I was born first and you were born second and our little brother was born third, you can't know from that information alone how many years separate all of us. And that's what makes it not be along a continuum. There is order, but it's not along a particular consistent continuum. So those are categorical measures under that particular umbrella. Let's move on to the continuous umbrella, quantitative, if you will. We have interval measures and ratio measures. First, we'll talk about interval measures. Interval measures pertain to numerical variables along a continuum with no true or absolute zero. Once again, numerical variables along a continuum with no true or absolute zero, right? So there is a continuum here, meaning that the distance between 1 and 2 is the same as the distance between 2 and 3, which is the same distance, same as the distance between 3 and 4 and 5, and so on and so forth. So the continuum is there, but there is no true or absolute zero. What a true zero or absolute zero means is that at the 0 point, the particular concept that we're studying does not exist, right? And we'll give you, I'll give you some examples of that, so this way hopefully it becomes a little clearer. The first example will be IQ, intelligence quotient. It is not possible to get an IQ score of 0. You could have a very low IQ score, you could have a very high IQ score. We're not really talking about the higher end in these examples here, but you cannot have an IQ score of 0. It's impossible. So even though the difference in IQ between 1 and 2, let's say, or let's say more realistically, the distance between 70 and 100 is the same as the distance between 100 and 130, there is no true or absolute zero when we're talking about intelligence quotient, when we're talking about IQ. Same thing with credit score here. The lowest credit score you can have is 300. Hopefully that's not your credit score. Hopefully it's closer to 850. But again, you see that credit score, even though the difference between 300 and 400 is the same as the difference between 400 and 500, there is no absolute zero, thereby making it an interval measure and not a ratio measure, which we'll get to in a little bit. Now here in Likert scales, for example, if I were to take some data and put it on a Likert scale, let's say it's a satisfaction study, and on a scale of 1 to 10, how much are you enjoying this video? Let's say you're enjoying this video a 5 out of 10. Hopefully you're enjoying it a little bit more, but let's say you're enjoying it at, on a scale of 1 to 10, it's a 5 out of 10. And let's say I wanted to collect that information from a group of 200 people. I could choose to look at this, the Likert scales, in a numerical sense and think of it as a continuous, artificially continuous measure. And the reason why it would be artificial is because your 5 might mean someone else's 7, which might also mean someone else's 3. Who's to say that the 5 is exactly based on a consistent style of measure? What you think of as a 5 out of 10, someone else might think of as a 7 out of 10. Someone else might think of as a 3 out of 10. You don't have an sort of like an intrinsic understanding of what those differences would mean and how you would measure them. So therefore, you have order. You know that you're enjoying this or not enjoying this, but you don't know how much more you're enjoying this or not enjoying this versus something else. But again, in the name of research, artificially turning Likert scales from ordinal measures into interval measures helps to come up with those measures of central tendency that I talked about, mean, median, and mode, as well as the measures of dispersion that we talked about that are range, variance, and standard deviation. Temperature is a little bit fuzzy here. Temperature is fuzzy because when we're measuring temperature in Fahrenheit or Celsius, when it's 0 degrees Fahrenheit, it doesn't mean that there's no temperature. It just means that it's really cold. When it's 0 degrees Celsius, once again, doesn't mean that there's no temperature, that there's no thermodynamic activity. Rather, it just means that it's really cold. So when you're measuring temperature through Fahrenheit or Celsius, there is no true 0, right? Therefore, when you're measuring temperature through Fahrenheit and Celsius, they are interval measures of temperature. You can responsibly state that Fahrenheit and Celsius measures are interval measures of temperature. Next, we have ratio. Finally, we have ratio. Ratio measures pertain to numerical variables along a continuum with a true or absolute zero. Very similar to interval, with the only caveat being instead of with no true absolute zero, now with ratio measures, you do have a true or absolute zero. Here you might be thinking of height, you might be thinking of weight, you might be thinking of age, you might be thinking of temperature. Now, let's start with height. If you're 0 feet, 0 inches, 0 everything tall, you don't have any height. You cannot be negative inches tall, right? Therefore, this is a true zero. You can't go in the negative direction, number one, like you can possibly with Fahrenheit and Celsius. You can't go in the negative direction. And when you're at 0, 0, 0, 0, 0, 0, there is no height. The phenomenon or the concept of height, as far as this particular individual is concerned, doesn't exist, right? So that is a true and absolute zero. Same thing with weight. If you're 0 pounds, if you weigh 0 pounds, you have no weight, right? Or 0 grams, 0 ounces, 0 everything, right? If you have no weight, then you have no weight. You cannot go in the negative direction with weight. And you also, once you hit 0 pounds, 0 ounces, 0 everything, you don't have weight. Same thing with age. Sounds kind of like obvious, right? If it's 0, then it doesn't exist. If you're 0 years, 0 months, 0 seconds, 0 milliseconds old, you do not have age. You don't even exist, in fact, right? In fact, if you don't have height, if your height is 0, if your weight is 0, if your age is 0, you don't exist, right? The phenomenon of you doesn't even exist. So think of height, weight, and age as good examples of ratio measures because there is indeed a true zero, and there is no, there's a true zero, and there's consistency. It's along a continuum. So if you age by 1 year, when you go from 36, let's say, to 37, it'll take the same amount of time to go from 37 to 38, and it'll take the same amount of time to go from 38 to 39. Now, temperature is interesting here as well. Temperature is a ratio measure when you measure temperature using the Kelvin method. When you use the Kelvin method, you do have an absolute zero. You do have a temperature at which you've achieved absolute zero. 0 degrees Kelvin is very, very, actually it's not very cold even, it's the absence of thermodynamic activity. So if you have 1 degree Kelvin, it's very, 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 very cold, but once you hit 0 degrees Kelvin, there is no such thing as temperature anymore. There is no such thing as temperature anymore. So when you're measuring temperature and you use the Kelvin method of measurement, that particular thermometer, if you will, then it is a ratio measure because you cannot have a negative number in Kelvin, and every number that you go up is doubling from what you've had previously. So when you go from 1 to 2, it's a difference of 1. When you go from 2 to 3, it's a difference of 1. When you go from 3 to 4, it's a difference of 1, so on and so forth, right? So not exactly doubling, but going up by the same increments. So when you're at 0 degrees Kelvin, it is an absolute zero. There is no such thing as negative any numbers in the Kelvin scale, right? So it really depends on how you measure temperature that determines whether or not it's an interval measure or a ratio measure.